Good morning, everyone. Welcome to the C++ course. Today we'll be looking at how to adapt object-oriented programming. So before we learn any new concept, we have to understand what is lacking in that particular approach and why we need something new. So in terms of programming, I'm just going to demonstrate with a simple example of what a procedural programming is. This is what we have been doing all this time. And then what is the advantage of adapting to object-oriented programming. So let's look at procedural programming. Okay, so here's an example. Let us say that we want to calculate the area of a rectangle. So in procedural programming, the approach would be to think about all the different tasks for that particular requirement. We want to calculate the area of a rectangle. So what are the steps? Step 1 is going to be get length and width. Step 2 is going to be calculate area. Step 3 is going to be display area. So these are going to be sequentially done. And so step 1, step 2, so we have to finish one step before we go to the next step. So this is how we think about it. We are not thinking about, or rather we are specifically thinking about a specific task that we want to accomplish. The task is to calculate the area of a rectangle. So that is what procedural programming is all about. So what happens is, if you think about an object, a task-based programming is going to only look at one aspect of that particular object. So a task is not going to give us the big picture. It is just going to be giving us a small, what do you say, like a viewpoint. So in order for us to be able to see the overall 360 degrees, instead of thinking it in terms of tasks, we want to start thinking in terms of a real world approach, or a 360-degree view of whatever is in hand. So let me explain what I mean. So here we are thinking, what do I want to accomplish? What are the steps I want to accomplish to calculate the area of a rectangle? That's what we are thinking. Instead of that, instead of thinking about what are the steps I need to accomplish this task, we want to think about what is at the core. What is at the core of this operation? What is the main? You can think of it like if you have a play, who's the protagonist, right? So in terms of that, like what is it, the main concept or main theme? What is the central point of this particular approach? So if you think about the central point, it is just that there is a rectangle. So there is a rectangle. We are acknowledging that there is a rectangle. And then we are going to be looking at, it has length, it has width. And then one of the aspects of that is area. So we are calculating area. So while a procedural programming is going to only let you focus on this, an object-oriented programming lets you focus on all of this and more. Okay? And that is why we want to be able to design and model things using object-oriented programming as opposed to procedural programming. A procedural programming is going to be task-based, whereas an object-oriented programming is going to think about the modeling of that particular object. So let's think about it. So we have a rectangle. So in object-oriented programming, so we could have a rectangle that has length and width. Okay, so there are two aspects to this. So this rectangle could have some attributes, and there could be some actions. So let us look at it. So this rectangle can have length, then it can have width. Maybe then we want to decide if it is filled or not, like the color. Does it have border? Okay, what is the color of the filling? What is the border color? What is the border style? So we could have a rectangle that looks like this. So these are all going to be additional things that we can add, additional attributes that could define this particular object called rectangle. So these are attributes. Now let's think about methods. So we probably want to like draw the rectangle. We can draw a rectangle. We can change the length, change width. We can set color, set border color. We could set border style. So this is a holistic approach to coding. Okay, as opposed to thinking about just this one aspect, we could calculate area, perimeter. Okay, we could calculate the main diagonal, the length of the main diagonal. Okay, so there are so many things we could do. We could calculate the center point of this rectangle. So I mean, there are so many ways this can be sliced and diced. So instead of just focusing on a tiny aspect, this, and this, now we are thinking about holistically all the possibilities for our particular application, so that using this one object we are able to manipulate and assign so many different things. So let's look at what's on the right side, the attributes. When you say attributes, so it defines how a rectangle is, how an object is. Methods define what kind of operations can happen with that particular object. So you could draw a rectangle, you could change the length of a rectangle, you could set the color of a rectangle. So what happens to the rectangle? What can be done with the rectangle, or methods? Attributes define the look, feel, or any kind of it defines the rectangle itself, the aspects of a rectangle. Okay, so this is how we would just create or we would just think about an object in terms of attributes and methods. Okay, so now let's think about it. We all know that in order to do a house, build a house, we need a blueprint. So let us say I have a blueprint called A. I use that blueprint to create my house, and I use the same blueprint to create, so let's say call my house as X, and then I create another house for my brother, that's Y. I create a third house for my friend called Z. I use the same blueprint. Let's say the house looks this way. It is a 3-bedroom, 3-bathroom house. Let us call it as a ranch style, and then it has its own attributes. Let us say that this is the blueprint I use to do all the 3 houses. So the Z was created this way, X was created this way, Y was created this way. Okay, so the blueprint is not really a house. It is the imprint of how the template of how a house should be. There it is an abstract, right? So a blueprint is abstract, but these houses are not abstract, they are real, right? Somebody constructed them, and the 3 of them will be identical. The color of the house might change, okay, so the materials used might change, but overall the plan will be the same because the blueprint defines the plan. So the thing is, they have different addresses, they have different owners, They have different addresses, different owners, but they all came from the same blueprint A. So if we extend this concept to our rectangle example, okay, when we say a rectangle, so if you have a class, the class is a template, okay? If we have a rectangle class, this is the blueprint, and I could create any number of rectangles. So this rectangle could have length equal to 3, width equal to 5. This could be length equal to 2, width equal to 2. This could be length equal to 4, width equal to 3. Okay, they all have length, width. All of them will have these methods because they all come from this rectangle class. So this is called as a class, and these are called as objects. So these three, this is called as an object. So class and object. So a class is a blueprint for an object. But a class does not exist in reality. It is just a template. If you want to actually use the class, you have to create an object. Okay, so from a class, you write an object, and that object will call the attributes and the methods. Okay, that object will call the attributes and methods defined inside the class. That's how we have to use it. So if you have a class, for example, if I have a class called cat, that is my class, and I want to create Tommy, that's my cat. So what I would do is I would actually have to create Tommy from cat, and then Tommy will be able to use all the attributes of cat and methods of cat. Okay? Okay, so we just looked at what is a class. A class is just a blueprint. An object is going to be an implementation of the class. Class is abstract, object is not. A class has attributes and methods. Attributes are how a class is defined, like the features you can think of. And then methods are going to be like some of the actionable items with that particular class. Both attributes and methods can only be applied to the objects, not to the class itself. So we can define what an attribute should be, what a method should be in the class. But in order to make it actually work, we need to work with an object because it is not abstract at that point. So the other thing I want to talk about is relationships. What type of relationships they have. So what kind of relationships classes can have. So when initially the classes are simple, right? But then when you come to have like complicated situations, you could have relationship has a relationship, okay, which means inside a class there could be another class, or so that's called as an aggregation. So inside a class you have a class, or inside a class you could have an object that is calling another class. Okay, so this has a relationship can be either aggregation or composition. Then there is another relationship called as ISA. So this is where we talk about inheritance. Okay. So when I say has, for example, a person has address, right? So if you have, this is a person, this is the address class, every person will have an address. So a person has address, okay? And when you think about a person, so address can live by itself. We could have address by itself as a class, but then a person class will have one object that is an address. So this is one type of relationship. The other type of relationship is called as inheritance. So, for example, animal and cat. Okay, cat is an animal. So, you could have a parent child relationship, which is called as the is a relationship. Is a. So, cat is an animal, person has address. Okay, cat is an animal, person has address. So these are other types of relationship. Once you create and get comfortable with classes, then when multiple classes come into place, come into the scene, then we have to figure out how they are related, and that is when these relationships come in. We'll be looking at this more in depth later on. Some other terms I want to talk about. Encapsulation and abstraction. So in object-oriented programming, these two terms come a lot, and I just want to talk about what these mean. Encapsulation. So the concept is, if you define a class, everything about the class should be inside the class itself. That is called as encapsulation. That is, you want to make sure everything that defines a class is kept within the class itself. And it is self-contained, so we don't have any dependency on external things. That is encapsulation. Abstraction. Abstraction is like if you have a car, you should know how to drive it. You don't have to know the inner workings of the car. Okay, you don't want to look under the hood and know all the details in order to drive the car successfully. So you want to make sure that by using a class, we create a layer of abstraction. So there is just this magic. Like for example, when we talk about the example of the rectangle, as a user, nobody has to know how these functions work inside. How do we draw a rectangle? How does that work? All they need to know is they should be able to use the draw method of the rectangle class, and then it should do its job. It should give an output like this. They don't have to know how it was implemented inside the class. That is the business that we want to keep hidden from anyone that is using the class. So I could be somebody, I may not be the owner of the rectangle class, but if I have access to use it, I should just be able to use any of these methods and properties without knowing how they are implemented internally. That is abstraction. Okay, so basically we hide implementation and then we want to make user friendly methods. So we don't want people to be able to worry about complicated details of implementation. So everything should be easy. That is called as abstraction. That is abstraction. Encapsulation, everything, like for example, like properties, which is attributes, and then we have methods. So it comes as a package inside so that there is less dependency and everything is in one place. So that is encapsulation. Okay, so I hope this video helped you understand object-oriented programming, the purpose of it, the difference between object-oriented programming and procedural programming. What does a class look like? What's the difference between class and object? And then some of the relationships that we could have. Thank you.